Hello students. In the previous video we have discussed about Earth's average mean temperature, which we have calculated using Earth's energy balance model as minus 19 degree Celsius. But in actual the Earth's temperature is plus 15 degrees Celsius, so there is a difference of 34 degrees Celsius. So today we will discuss the reason behind that, why in actual Earth's temperature is plus 15 degrees Celsius, and as per energy balance model it was calculated as minus 19 degrees Celsius. So the reason behind the difference is the atmosphere. We have neglected the atmosphere, and we have neglected the very important effect, that is the greenhouse effect. So we'll discuss in detail about the greenhouse effect and the greenhouse gases and their warming effect in this video. So in the previous part we have assumed that the outgoing radiation emitted by Earth escapes directly into the space, but in reality the atmosphere absorbs a portion of these outgoing infrared radiation, and the interaction between the outgoing radiation and the atmospheric gases produce greenhouse effect. So that's why our previous model was incomplete. So let's go to the next slide. Now sun emits shortwave radiation and earth emits longwave radiation. What does this mean? This means that as we know, sun has a very high temperature around 5800 Kelvin, so it emits short wave radiations, and earth has a comparatively low temperature of 288 Kelvin, so it emits long wave radiations. So this difference in wavelength between the solar radiation and the terrestrial radiation is the reason that greenhouse gases can trap heat. So why sun emits short wave radiation and earth emits long wave radiation, this we will discuss in the next slide. Now, according to Wien's displacement law states that the wavelength lambda max at which any black body emits the radiation most intensely is inversely proportional to its absolute temperature. So here lambda max is inversely proportional to absolute temperature of that black body. So here 2898 meter Kelvin is the Wien's constant. So this Wien's displacement law is the reason why hotter bodies emits radiation at shorter wavelengths and Earth emits radiation at longer wavelengths. So by putting values into this equation of lambda max and temperature value for Sun and Earth, we'll get lambda max for Sun at 0.5 micrometer, and for Earth we'll get at 10 micrometer lambda max. So that's why Sun emits radiation of shorter wavelength and Earth emits radiations of longer wavelength, that is infrared radiation. So now what are greenhouse gases? Greenhouse gases are radiatively active gases that absorb and emits infrared radiations, that is especially the radiations of wavelength greater than 4 micrometer. Examples of greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. These gases allow most of the incoming solar radiation to pass the atmosphere, but they absorb the outgoing terrestrial radiations and they cause the greenhouse effect. Now, this selective absorption of the greenhouse gases is the mechanism behind the greenhouse effect. Due to these gases, solar radiation easily reaches the Earth's surface, but the terrestrial radiation got absorbed by these gases in the atmosphere. So now let's come to the next slide, that is molecular absorption mechanism. This is very important mechanism. Now when a greenhouse gas traps outgoing radiation, that is infrared terrestrial radiation, for that gas this radiation is the incoming radiation. So when the frequency of the incoming radiation matches the frequency of vibration or rotation of that gas, it absorbs the incoming radiation. When it absorbs the incoming radiation, which is outgoing radiation from the perspective of Earth, the molecules get excited for that particular gas, and when they get excited and when return to their normal state, they release photons, and due to collision and photon energy transfer, this energy got transferred into the nearby air molecules, and that causes warmth, that causes heating effect or warming effect. So that's the basic mechanism behind this molecular absorption. So now this produces absorption bands at specific wavelengths in the infrared region. Next is atmospheric window, which is from 7 micrometer to 13 micrometer, as you can see in the slide. What does this mean? Atmospheric window means the outgoing radiation of wavelength between 7 micrometer to 13 micrometer can easily escape directly into the space. The greenhouse gases does not trap or does not absorb the outgoing infrared radiation between wavelengths 7 micrometer and 13 micrometer. That's why it is known as atmospheric window. This atmospheric window plays an important role in maintaining Earth's energy budget. So now re-radiation by greenhouse gases. As I explained earlier that when the molecules of a greenhouse gas got excited by absorbing the outgoing infrared radiation, and when the molecule get de-excited, it releases energy in the form of photon in all the directions. So that some of that energy goes into the space, and some of mostly part of that energy comes again into the atmosphere, and then with the collision effect with the surrounding air molecules, our atmosphere gets warmer or hotter. And this re-radiated energy by greenhouse gases, which is coming directly towards downward, and this re-radiated energy by the greenhouse gases, it comes downward towards the earth's surface, and it warms the planet. So the atmosphere behaves like a thermal blanket around the earth. So it traps the outgoing infrared radiation and increases the earth's average mean temperature above the predicted temperature as predicted by the energy balance model. So as a result of this greenhouse effect, Earth's average mean temperature increases about 34 degrees Celsius, that is from minus 19 degrees Celsius as predicted by the energy balance model, to plus 15 degrees Celsius due to the greenhouse effect. Thank you so much.